Professor, I had a question about the lab that was due.
Yeah, okay.
So before you, in your last lecture, you were talking about doing things with Makefile, and I just wanted to know for that lab, did you want us to do the functions in a Makefile, or is it fine to just write it all in the one CPP file? Just
No, I prefer you do in the Makefile. That's the reason this lab has a little bit longer time because as we're moving forward, everything has to be in the format. And this probably is the easiest way of doing it since you still have another week to finishing up.
okay. Yeah, my last class, he didn't go over Makefile at all.
If you read my material, I even have a Zoom session talk about Makefile. Just follow the instructions.
Okay, so the because I saw that you said something about having a Zoom file about it. It's inside it's somewhere inside in Canvas.
Yeah. So let me see. Hold on. So you should be able to see it. Just hold on here.
It you basically just
Here, right here. How to use the Makefile here.
oh okay.
So I have this one. You should be able to view it. So here, have you tried this?
No, I actually couldn't find. I was looking for that and then but
Yeah. So it's right here. So if you go to here, right? So inside software development, how to use Makefile.
okay. All right, thank
Yeah,
you.
and now I'll walk you through step by step.
Yeah, it seems pretty simple. I mean, from just watching you do it on the
Just
video.
yeah, just go try to watch my video. If it still doesn't work, the tutors, all of them know how to using it.
Okay. All right, thank you, Professor.
Yeah. Okay. So good morning. So this is 116 class, and let's just talk about some of the schedules. So by now, all of you should have read this, and also there's a student consent, okay? And I see some student has not done that. So the consent pretty much means is, for example, right now you ask me questions using audio, and they want to make sure you actually it's okay since I'm recording the session. So please do go in there, this week to finishing up. Another thing is as a part of the assignment, you also need to finish this course survey. And I see about 80% of you have done already. So another 20% has not done it. Make sure you do this, okay? So this one is really try to make sure you have the responders lockdown browser set up because all the tests will be like this. And I don't want to be on the day of the test, you are trying to figure out how to using this, okay? So it's a very simple, straight format, a survey, but it's pretty much testing the responders, the lockdown browser. And other things is lab one, as we just talked about, it's breaking them up using functions and the Makefile. So the Makefile is, it just go here. I have a, very detailed instructions. I went step by step on that. Help, the tutor can help you as well. And then for some of you actually has already finished lab one, which is great. And then I also published lab 2 here as well, so you can get a head start. And so today's topics is talk about the vectors and talk about array and pointers. So I just did push a little survey to you guys, and can you try to answer the survey for me so I have some ideas on where everybody's at. And so today we're gonna talk about, let me go here. Okay, so well, that's good. So majority of you covered array, which is great. So I'm not gonna go over too much. Half of you cover vector, half of them talk about pointers, which is good, which is good. So that means I can go a little bit quicker on this because all those kind of things we will utilize in this class. Okay, and so now let's talk about array. So since everybody already know about array, so I'm gonna quickly just go over it, right? So the key things is, let me just go to the summary of array. And so array, one of the key things about array is a fixed size, is not dynamic. And so that you have to predetermine the size of the array when you're using it, before you're using it. And once the size is defined, you cannot change that during runtime. And so that is really one of the major difference between array and a vector. And so for example here, right? So it's an array. And so let's see how they define it. Oh, here it is, right? So here you're defining an array, right? So the array, here is a variable, here is a capacity. Capacity means the size of the array. And typically you're using a constant. The reason is the array size never changes once you compile it. And here's data type. Data type can be any valid data type. And so whatever you put in here, you cannot go beyond the capacity side of it. And so one of the things about array is not only you have a capacity, you also have to keep track of where you're currently at. So maybe you have a capacity of 100, but in this case, you only use the 4 element, and the rest of them is empty. So you have to know where you are. So you have to keep track of this current size yourself, right? That's what array is. The other thing is we all know everything starts in indexing. Everything starts with a 0. So if you start from 0 and this capacity is 10, well, the last element is 9. So if you do a 10, you would have outbound issue. Your program may work or may crash, or so you don't know, right? Depends on whether you're accessing any location that you're not supposed to access, right? So so that is array. So then we move on to vector, right? Vector is half of you say you never covered it, which is fine. If you know about the array, vector is very similar to array, and but it has some of the major benefit compared to arrays. So earlier I mentioned array is fixed in size, and whereas a vector, on the other hand, is not fixed in size. Okay, and it's that sometimes we call this vector is a dynamic array. That means during runtime you can increase the size of the vector or of the the dynamic array, whereas array is fixed in size. Once you define it, once you compile the program, that is a size. If you want to change the size, you have to recompile your program. Whereas a vector, you don't have to. Okay, you don't have to, because during runtime you can just increasing it automatically. So the format of defining a vector, right? So whereas array you have a data, then here you have a little bracket, right? The size. Whereas a vector is like a vector. So this is a system function, right? System a class object, which we're gonna learn in this class. So vector is implemented in class object type format. And then here is a data type. Can be whatever data type it is. So double, int, string, or a class object, wherever the sense it is a valid data type, and that is what you have, right? So in this case, they defined a vector of integer. So it's similar to if you're saying in the array sense, then it would be int counts, and here's the size, and then become an array, right? For vector, this is the format. So this is a vector of a string, and by default, a vector is empty when created. So when you create it like this, the size is 0. There's nothing there, okay? As you start using it, it will just increase the size automatically. Or ahead of time, you can predefine a size. So what happens is during runtime, it will allocate a size of 10 elements inside of the vector. But what happens is, well, I now have 11th element to put in there. Not a problem. During runtime, you will automatically create an additional element so you can put it into this data vector, right? So by using this way, if you know at a minimum you have a 10 element or 100 element, so you probably want to do this way, because during runtime, during compile time, it already allocate the space for you. So during runtime, you don't have to reallocate. So that means the thing is running faster because you already have all the space being allocated. But you don't have to, right? Even you have a 10, it doesn't mean this is a size limited to 10. It can still go to 20, 30, 40 during runtime. So here is an example of a vectors, right? So you have a integer, a vector of integer, and a vector of integers, as I mentioned. So this is only during compile time. It will pre-allocate this much memory space for the vector integer, but during runtime, you still can increasing it, not a big deal. And so if you don't know the size, you can just use an empty one like this, but never use this empty bracket, empty parentheses. If you don't have anything, just use the one like this one. Now, and the way to put something into a vector, just like you're adding an array, right? So here is an integer, a vector of integers, and then you say, okay, I want to put 10 elements into the vector starting from 1. Okay, so I have a number is a 1 through 10. So the way you're using it is using what we call the pushback, right? We call pushback. So then you can use it for I equal to 1 less than 10, and numbers is this, right? Is a variable. Then dot, okay, put a dot, and pushback. Pushback is a function, okay? It's a class object function part of this vector, okay? And so you're using pushback to add an element into this vector integer of it. And so then other sense is they say, okay, and since a vector work almost the same way as array, sometimes you can use the array assignment as well. But this is not a typical people use, okay? Because this is people usually using a pushback, okay? And so try to just using this one and using a pushback. The other thing is for initialization, you can also pre-assign the element to it. And so here just some pre-assignment. So this vector 0 is 1, vector element number 1 is 2, so on and so forth, right? So that's a vector side of it. And so then other things is a vector, it's the way you accessing the vector is similar to array. And so then you also have to worry about the bound, size of the bound. For example, this one just initially to a 4, but then you try to accessing it without adding something to it, then you have a problem. So then a vector also has another one we call pushback, is add element to it. Pop back is to delete an element. So let's talk about the, what does a pushback do? Okay, pushback by adding an element. So earlier I mentioned, right? And earlier I mentioned that in array, you have to keep track of the how many elements in there, right? So in array, you have to keep track of this current size. And whereas a vector, on the other hand, you don't have to. Everything is done automatically. And so that is what the pushback does. So pushback simply just add element into this vector. At the same time, it will increase the size by 1. So you keep track of it. And the pop back will delete the last element in the vector, the last one, and then decrease the size by 1. Okay. So here is an example of it. So you have a vector, right? So this is a double and can be any data type. And they say, okay, push back 32. That means I want to add a value 32 into this double value vector. And then this is automatic increase the size. So now when you start it, size is 0 because there's nothing there. So once I add 32 there, right, the size become 1 because I have 1 element. If I add 54 there, the size become 2. That's what this one is, right? Once I've done this part, there is 2 now because I have 2 elements, 32 and 54. And I did it again, push back, 37.5, then it become this. So this size, this one is automatically incremented by 1. So now it's a 3. So pop back, once you do a pop back, it will take away the last element in the vector. So in this case, it's a pop back and 37. This one is gone. And the size also decreased by 1. Okay. So when you do a pop back, what does it do? It will release the memory space of this element back to the system so you can be using it. And so if you, for example, right, so if we did this one and, let's say over here, right? So we did it here. And so you have values, 0, right? And the value zeros, in a sense, is 32. And value 1, right, is 54. And the value 2, right, so 0, 1, 2 is 37.5. So the way you're accessing it is similar, okay, to array, right? And once you're removing it, say, for example, I removed this, right? And if I try to access values 2, right, because nothing is there anymore, your program may still give back you 37.5, but it may not. It also may crash, right? Because the reason is this one is no longer a valid, right? Because I removed I did a pop back, so the last element is removed, so the size is 2 now. Okay, size is 2, so the 0, 1, right? So 0, 1, and 2 is not valid anymore, right? So just be careful, you still have the bound arrows, okay? Any questions on this? Okay. Now, other things is, they talk about how you can using seeing to get input, and you just keep using value.pushback, okay? Now here is the data type to it. And so now here is, this is array, right? If we're using an array, and the array, you have to know the size, right? And then you can print it out. And if this is vector, if the size is less than 10, you can still do the same thing. But the whole idea about vectors is I do not have to keep track of the size. it's automatically done for me, right? We already seen here. It are automatically done for me. So I already know the size. And so since I already know the size, what do you think? You know, I mean, what should I do here, right? So you can use this. For I equal to 0, I, so this is a function as a part of the vector of the values. And this is what we call member functions because it keeps track of the size. So now you can use in this, right? Versus you, the one in array, you have to keep track of yourself. This one is being tracked by the system automatically. And so here is just an example of you add up all the value in a vector, right? So I mean the whole idea is you can use the size now, and the way you access the element, in the case this is a simple data type. When we talk about simple data type, it's only one, like integer double string is only it's not a structure type sense, which we're going to talk about today as well. And so you can just accessing like that, right? And so then you return, unlike array. If you if you refresh your memory in the array, and you pass array in here, they call that you always pass by reference by default. You don't have to do anything. Vector, on the other hand, is pass by value. Pass by value means is it make identical copy inside this function. Okay, that's what I mean by pass by value. And the pass by reference is doing the pointers. And then I'm gonna talk about pointers. We can gonna briefly mention it. So it will pass by pointers is called pass by reference. In this particular case, is a pass by value. If you want to turn into a pointers pass by reference, you add this ampersand sign, okay? And that's what this one is, right? So now I'll go pass by reference. So pass by, what does it mean by pass by reference? Well, pass by reference means it's, I just pass the pointer to it. So I don't have to make a copy. For example, if this vector, right, let's just say it has 1,000 elements. If have 1,000 elements, in this example, I have to copy the 1,000 element into this function before I can using it. Or just say I have 1,000,000 element. Can you imagine how your program gonna perform? Maybe you're gonna run out of memory because you have to make a copy of it and it's gonna be very slow. Whereas this one, it just simply point to the pointer. So it's much efficient and much faster. But the key sense is if you do this, you have to make sure the value don't get changed, right? And because now you can make a sense of changes to it. And so it's really for efficiencies, you do pass by reference. Well, earlier I said, well, you have to make sure maybe you don't accidentally changing it. Well, not a problem, right? So if you're simply passing the sense by pointer so that you can speed up your program, but not changing it and make sure people don't accidentally changing it, right? You put this constant there. Constant means is, well, I pass by pointer, but I will not allow you to changing it. So now you have the efficiency of using a pointer without worry about accidentally making a change to some data, right? And passing by value, nothing getting changed. Everything changes is inside here, so you don't worry about it, right? But it's inefficient if the vector is very large because it has to make a copy. And the reference parameter, since you pass by pointers, since it can get changed, but it's very fast because you just passing a pointer over. And if you don't want the sense to get changed, you add a constant to it. Okay, so if you have any questions, just using the chat or unmute yourself, ask me questions, okay? And so now that's,
I got a question, Professor.
yeah, go ahead.
So if you wanted to just within that function that you use the constant vector in, could you temporarily change that data if you wanted to, and then
No,
once it's
no,
out
no,
of
no, no. So once you put a const there, if you try to changing it, actually the compiler gonna give you error,
okay,
and which is good because compiler double check. So you cannot, if you put a constant here, if if you make a changes, try to make a changes to this, compiler will give you error, right? Whereas this way, it will not give you error because maybe you do want to make it a change. He doesn't know, right? Yeah.
got you. Thank you, Professor.
Yeah. And so then other things is the key things is here they talk about vector, right? So the last element of the vector, right, is the size, because size, when we talk about size, we count from 1, 2, 3, 4, 5. But when we accessing, we start from 0, right? 0, 1. So the last position is always the size minus 1, as what they're saying. Okay. And so if you want to remove the last element, you can do that, or you can just do a pop back. We always remove the last one anyway. And when you traverse through a vector, always using this because it automatically know the size, okay, for you. And then a vector actually has a lot of great features. So you probably want to take a look at it. And for example, there is a library function in C++ called algorithm. Algorithm has a lot of functions that you can use. For those of you taking CS 124, they talk about data structures, algorithm. And of course, you cannot just use a system defined. They can ask you to implement it. But many of those functions has already been defined. For example, there's a sort, right? So as we know, this is a vector, and you can sort the vector, and you also can pass in a function to it how you want to sorting it. So once we go to class object, I'll give you an example of that. But this one pretty much a sort. If this is an integer, or this is double or string, this value, it was sorted in the order you want, just like a descending order or ascending order, right? So you can sort as well. And I'm not going to cover this too much. And just like a double array, a two-dimensional array, you can have two-dimensional vectors. And so I'm not going to cover that. And which to use? People say, well, when do I want to use a vector and array? And based on this, can somebody tell me when do you think it's best to use array, when it's a vector, or it's always best to use one or another? Anybody?
I think when you don't know your array size, it'd be better to use a vector if you want to keep things dynamic.
That is correct. And but if you know the array size, then then you probably should use arrays. So the key thing is, if you know the size, it's efficient to use array, because during compile time, it already allocate all the memory for you, and you know the size will never increase. For example, if I know my class size is 30 students, it will never go up more than 30, for example, right? Or for example, our and there's 2 senators for every state, so won't never be 3 senators from any given state. So we have 100 senators from 50 states. So unless we add another state or change our constitution, which is not likely, so in that case is you probably just use array, because it's a fixed size, is known size, and it would be much faster. Whereas vector, the reason is slower because during compile time, you have to allocate the memory. But it's much flexible, and you can change the size. And that is the reason actually people using vector quite a bit, because it's flexible. And with the computing power getting more and more powerful, it's not a big deal anymore. And for using a vectors, unless it's a very, sensitive, maybe if you, are doing game development, if you already know, the size, you probably don't want to use a vector because you want to speed things up, right? And also vector has a whole bunch of functions you can utilize. So if you search online, talk about C++ and a vector, so it should give you all those library functions, right? And so here has all the library functions you can use, right? And you go, play with it. So far we talked about pop back, right? We talk about pushback, right? And also they have so many things you can erase and also know where things are at. So there is a lot of functions you can use, okay? Now, and so another thing is I talked about earlier, right? You can use a for loop for integer equal to 0 and to the size. You can also use this kind of format. So this is a C++11 format. So you can use the integer v, okay? Just like the integer I, v, and colon and values. Value is this vector. So what it does is it will just automatically traverse and traverse through the list. And so there's a question is, can you put a vector inside a vector? Yeah, you can have a vector over vector. Yeah, you can do that, and so once we talk about also class object, now it make more sense because you also can have a vector inside the data structures, right? So it's pretty much it's very powerful, right? And then here is if you want to modify an element, so this is where you're passing a reference parameters now, right? And so anytime you see an ampersand sign, and that means it's a reference parameter, okay? And okay, so now so that's this one. And then another sense is, so now this is array, right? Array is, you can use the same thing for array as well. So that's the reason array and the vector are very much similar when you're accessing it. And then they also have another one called auto. So if you say, gosh, I don't know what P is, right? I don't know the data type. I don't keep track of it, right? You use auto, it will automatically determine the data type based on what you have here, right? The only thing is you have to make sure inside of the inside of your, when you try to accessing, the vectors or array is the correct format, right? For example, if this vector in this case can be integer, can be double, can be string, what happens if it's a class object or structure? Just by doing that, it most likely will not work, right? So we're going to talk about that in our class. So one of the key things is about array and vector, right? The way to access is it's the same. You can use in this index, right? And they start from 0 and to the the last element, right? You can use a for loop to traverse through it, and using reference parameter for vectors to passing the vector into a function and using constant to make sure nothing gets changed. Whereas as array, when you're passing it, you don't have to say anything. It always pass as a reference parameter. I don't know why they implement it that way. And because the reason I guess is they don't want people accidentally just passing a huge array into a function. We already talked about why when to using it, when not using a vector, right? And so if it's not a known fixed size, you always want to use a vector instead. And the key thing is the major difference is the size. Size can change for vector, array, it cannot changing it. Okay, so that is really the key things for it. And Okay, so now let's talk about another one. And
Professor,
yeah, go ahead.
I have a question about the vector. So you said the vector is like you can like the size is not fixed. It's not fixed, and
It's not fixed. Mhm.
and then why would we need to like declare the size then if that was like not fixed?
Why you create a size? You talked about earlier.
Yeah, you put the
Yeah.
number in the
Then
end.
that's good. So the reason for that is, for example, if you know when you start with and you have a minimum of, let's just using this class as example, right? So so right now I have a 30 student, but what happens if I say, gosh, this class actually can hold 40 student, and but I know I will always have a minimum of 30 student. And so I use 30. So during compile time, it will allocate 30 memory space for it. So then it's faster. But during runtime, if I want to change the 30 to 40 or to 50, and I can still using vector to changing it. So that because the vector by default is dynamic. But I can pre-assign a fixed size since I already know that many element in the vector itself. And for simple reason, it's to speed up for performance reason, because during compile time, it will allocate the memory space. Does that make sense? Yeah.
Yeah, thank you.
Okay. And so then let's move on to another one. And so I earlier asked about pointers. I think and half of you covered the pointer, half of you didn't. And so I'm gonna briefly also talk about, for those of you do not cover the pointers and try to catching up. And the way I'm gonna use the pointers is fairly simple, straightforward in this class. So you should be able to, after my lecture today, you should be able to understand. If you don't, just go read some more, okay? So what is a pointer, right? And earlier I talked about reference parameter. A pointer, a variable contains a value, okay? And a pointer specify where the value is located. And so it's like it's a link, okay? And everything you stored inside a computer has a memory location to store it. And so the whole thing is more of, okay, where things are at, right? And where is it point to, and you have to allocate the memory for it. And so we're going to talk about this later on in the semester, called polymorphism. And so you will change the things later on. So if you're looking at this kind of syntax, right? This one we all understand, right? We learned this on day one of CS 102, right? Double Harry account, so just give a variable and assign value of 0, right? So that is, when you're doing that, actually the system, the compiler will automatically store the 0 inside the memory and then have a Harry's account attached to it. And the other thing is, then you have here is also, I can declare another variable called double. Then I use a star. Star means a pointer. So now I actually define a pointer to a double, okay? So what does that mean? So if you look at the inside of your computer, we call it RAM, random access memory. And so when your program runs, it will start to allocating all the memories. So because your program set double Harry account equals 0, when the program runs, it already initialize, put a 0 there. It's similar to the question earlier, why I want to pre-allocate a size of a vector since I can increase ahead of time. Well, if you know the size, and during compile time, you're already placing all the memories and the value to it, so you speed things up, right? So in this case, because I said Harry account is 0, so I say, okay, here's a 0. And this is a memory space, can be anywhere. This is just for illustration purposes. When you run your program, this can be any number, okay? But this is the memory locations, okay? Located at this address, right? So then this is how you're doing it. So double Harry's account. So this is just a regular variables. But then you say, I also want to have a pointer and point to the double. So you define a double, here's a pointer. And then a pointer points to what? It doesn't point to 0. 0 is the value. But it says, oh, I point to the address of this variable. So that is the reason you put it as %. So remember earlier I mentioned the reference parameter. That's what it means. It's the address of it. So that means, right? That means Harry's pointers now point to this guy. That's where Harry pointer is at right now, because that's all what it was saying, right? So if you're looking at here, right? So Harry's account number, account pointer. So then you set, account pointer equal to address of Harry's account. Well, what is the address of Harry's account? 20300. So that's where it is. And then itself also has a memory space, right? So now this pointer is a point to this, right? So to accessing it, right? To accessing it, so now you look at this, double equal to 0, right? So this is a standard one, and then here is account pointer, right? So you're using the reference parameter, and so then you change the value. Have another one called 1000. Okay, so that's what this one. And then you say account pointer equal to address of the join account, right? Account pointer, and so now you have a point to this address here. Account pointer now is a point to the join account, right? So just thinking about this is just using an address of it, right? And so now, since you have a pointer to it, and so if you're accessing the value of the pointer, you always put a star in front of it. That means the value of wherever the sense is a point to. If you don't use a star, just say account pointer, you will use the address as itself. By doing this, you say, okay, account pointer, the value. Oh, what is the value of this pointer points to? So this one point to here. Oh, what's the value? It's a 1000, right? So now that sense is changed, by 1000. So whenever you change the value over there, and you actually change the join account as well, okay? And because they all point to the same place. Here is another example, right? Assuming, okay, here is the address for M and N, and here is the value. And then I said integer pointer, a pointer of integer equal to address of M, okay? So P, we already know, right? So P is, what is the P? Well, why is 20300? Why is that? Why P has this value? Well, the reason is, here I said is address of M, right? M%. What's address of M? In this particular case, and I said is 20300. That's what it is, right? So then I said the star of P, right? Star of P, that means the value of P, wherever P is point to. Well, we know the P point to the address of M. When I say star of P, that means the value of where is point to. So address of M, what is M? It's 10, right? So now it's 10. That's what it is. And so because this one is just a regular value, but I also can say, okay, what is the address of N, right? So here's 20. where the address of n is this, right? So this, just remember the address changes when you recompile your program, right? So now I say P, P is a pointer, okay, equal to address of n. So you cannot use P equal to n. You cannot do that because there's a missed data type. So P is a pointer, an integer pointer, n is an integer. So if you do this, that's not valid, okay, because they're wrong data type. And but you say, okay, since I want to point the address of P now equal to 20304, and if I accessing the value of P, now it's 20, not 10 anymore, because I point to a different place. And the M, since it's a variable M equal to star P, that means the value of pointers, you will get 20, right? And so you just have to make sure, if you want to get the value of a pointer using a star in front of it. And otherwise, it will just give you the address, right? And for a pointer. And for a value of a standard value, if you put ampersand, it will give you the address. Otherwise, it will just give you the value, okay? And then here has another one, right? So I talked about earlier, M equal to P. Well, M is integer, P is integer pointer. So it's a data type issue. You cannot have assigned to a different data type. And ampersand 10, you cannot do that. You cannot say address of 10, where address that we call is a literal value, right? It's just value. I mean, it doesn't store anywhere. So you cannot assign that, right? And so the other things is, since this is a pointer, right? If you're using the pointer address of P, that is totally someplace else. But why you want to use that? So just be careful when it's a pointer. You probably don't use the address because it doesn't have address, right? And since I almost never want to use the address of a pointer variable, it's just stored because there's no use to you, okay? And so then here it also has an arrow because this x is a double and p is integer pointer. So you have to make sure the data type matches, okay? And the other sense is, with a pointer, you have another sense. It's anytime you use a pointer, the memory space has to be allocated. Okay. Earlier we said this way, and when you're using it, because this memory space is already there. But if you never point to it, if you're just using this and start assigning it, and then it's incorrect because you don't have a memory space. And that's where you have to use a new, right? You have to use a new to allocate the memory space, which I'm going to talk about, right? So let me allocate memory space. And otherwise, you just always have something you use for it. And so let me see any more. And so other things is, take a look at this example, right? Integer a equal to 1, b equal to 2, the pointer equal to address of a, right? So now C out star p, and what do you think this one is? Anybody?
1.
Yeah, it's 1. Yeah, right. Then now p equal to the address of b, now star value of p is 2, right? That's all it is, right? So it just use a pointer. This is a good, simple example for you to understand the pointers, so that it's easier to follow. And the pointer also, can use array as well. So so I try not to talk too much about it because it's getting complicated. For our purposes, we're not going to use that. And so then, And then in the string, you guys talked about it. So now let me talk about this one, right? So earlier I mentioned, right, as a pointer, if you don't assign to an existing variable, and before you're using it, you have to use a new, okay? You have to use a new. And that means I allocate the memory space. But if you assign to another variable, which already have a memory space, then you don't need a new, okay? And however, once you use a new, you always have to remember to delete, okay? And because you allocate the memory space, and you want to make sure, and so you want to make sure that once you're no longer in use, and you want to delete the memory space, right? So the way I do it is always match. If I have one new, I should have one delete. Delete is when you no longer need the memory space. And the reason for that is you don't want your computer run out of memories, okay? So for example, if you have a for loop, keep calling a for loop, and keep allocating memory, but you're never releasing it, and pretty soon your program gonna run out of memory. I mean, I'm sure some of you probably experience when you're running up on your computer, if you didn't reboot or didn't restart the program, and your computer getting slower and slower and slower. The reason is all the memory has been allocated, and also maybe some of the program never freed up the memory. So if you if you take a look at your your performance side of it, so here's a percent more memory, right? You say, okay, it's how much memory is it using, right? Because sometimes you can say, gosh, this is using what, a gig of memory, because it just keep doing it, right? So so that's what you do, right? And to take a look at the system performance. But some program can start having more memory. We call the memory leak if you don't do a delete, okay? And once you're deleting it, you should just similar as a vector, you cannot use it anymore because the memory is not yours anymore.
Professor, I have a question about that.
Yeah, go ahead.
So should you delete it at the end of should you delete it immediately after you don't need it, or could you just always delete it in the main?
No. So let's look this way. Every variable has a scope, right? A scope means it's, let's just say this is a foo, right? Right, and so let's just say here, right? We have we allocate a memory, right? And so let's just say here we did double. Just use the integer star auto, and the star and the p, right? And let's just put it together, okay? P, and now I said it's just a p pointer, okay? And the new end, okay? And then from here, right, since I allocated, and I can just say, star p ptr equal to 10. Now I assign a value of 10 to it, right? And so then if I no longer need it, let's just say we have another program. So let me just make this a little bit smaller, and so you can see it, right? And right, so I have this, and then I have another one called the main program. Just say in the main. Okay, ignore this auto uppercase. Okay, and so actually this is a good example, and I call foo. Okay, let's change it. Okay, let's take a look at this example. What does that mean? So when I run this program, it's in the main program, it called this function foo, okay? And so once I did this, and if I did a cout, right? I just cout and star p pointer, right? And we know a 10 will be printed, will be output, right? And if I do the same thing here, and when you compile a program, what kind of error are you gonna get? Anything?
Yeah, the pointer won't exist in the main.
Exactly, it won't exist. It's not defined. But once you exit here, so it doesn't exist. So for example, I did this. Or worse yet, I did this. And worse yet, I did that. Okay.
That's a lot of foo.
Yeah, I know. But now here the issue comes in now. Okay, so let me make the things a little bit smaller. You guys can see it again, and let me make this smaller. Okay. Okay. So now see what happens. Okay. So inside here, once you exit it, this memory has already been allocated. And once you out of the foo, you no longer can access this anymore, but you keep allocating the memory, right? So this is what we call memory leak. Because once you exit this foo and this is out of the scope, and you cannot go back to see what it is. If you're finishing it, do a whole bunch of stuff, you should, once you no longer need it, you should delete, right? That's what you should delete, right?
Okay, so if you passed it as a pointer to the other one.
So if you did this, if this one, right, is an integer, there's just a p, ptr. Let's do that way. If it's a pointer, right, and then whatever the key sense is, whatever you use the new in the scope, that is where you need to delete it.
Okay. All right.
Or well, not there. As now you have access to this, right? You have to have access to this variable. So as not the access to the variable still exists, you can delete it. For example, if here, right? If let's do this way, right? Return, right? And p and pointer, right? And you make this right? You make the integer pointer, it will return, right? So then I can delete over here because I have the address. Okay.
Okay.
That's the key things.
Thank you.
Another question: can you make a pointer to a function? Yes, you can. And so actually, I have another example. Once we talk about the class object, and actually we're going to pass a function as a parameter. Because sometimes you want to do more. I will show you passing a function as a parameter, okay? Because just a pointer, that's all it is. It's just a pointer, and so I can point to a function and a pointer to a function, and then we can using it. And toward end of the semester, there's one example I will show you guys how to do that. Okay, so that is a quick review or overview. For those of you never cover pointers, so it's not a big deal, right? So it's just take a look at this PowerPoint presentations, so you should understand, So the key sense is here, right? You delete it. You cannot delete this one because I never did a new, and this is this arrow is. Because it's a pointer, right? You have to allocate the memory space, right? And to it. And so here is a good example. And so integer over new, and then you did another new of int. So now you have a new memory. So this one is being lost. So that is a memory leak right there, because you did a new, and you now this address is gone. You have no clue where it is at, right? And so this is just some more example of it. Okay, so that's on pointers, and so I want to let's go over another one. Then I'm gonna go over some examples quickly, and so. So I want to talk about this one. So this way, structures. Okay. Okay. So I want to talk about just quickly talk about structures. And so once we get into class object next week, and then we're gonna talk way more. So I don't know how many of you are using these structures. For the people that ever talk about pointers, they probably never did. So far we talk about the data structures, integer, double. A structure is like a record. You can place similar and a variable together and to create a new data type. So in this case, we create a new data type called street address, then has a house number, has a street name, right? And so now you have a new variable, right? That's what structure does, right? And so I'm gonna talk more about this once we go into a class object. And so I'm not gonna spend too much time talk about structures, because class object is much more powerful and then structures. But sometimes people still using this, very simple, just try to represent a data type. That's it, right? And so with that, let me go through some examples I have, right? And so we already talked about array, right? So array is not a big deal, right? So inside this little program, and it just traverse through array and put 10 random numbers to it. So here is random number functions, right? And so you will try to, getting a random number that is within 10 from 0 to 10. That's what it does. And also when using random numbers, and I don't know, you guys covered in your 102 class, and you have to what we call assign a seed. And so this is unique. So this way random is always random. And what is unique inside this world? One thing is unique, okay, is time. And because time never repeats itself. So that's the reason you use a time 0, that means the current time. Every time you run this, it will have a different seed, right? So because time is not constant, time keep changing, right? And so this one, once you run the program, right, and it will generate the numbers for you, okay, and tell you the first one and last one as well. And I'm gonna post this example in Canvas, so you can have you can access it. Okay, and so let me go through a couple other examples.
Hey.
And so here, array in the vector. Let's do this one. I did a one called makefile, right? So in this one, as a makefile, right, and which you're gonna try to use watching my examples. And so this one, I say, okay, I have a best customers, and have all those files, right? So here is the main program. And so what does the main program does, right? It asks you to input, right? So this is where in your current lab, right, I also ask you to do validations, right? Here I have a little example, while not done, right? Then I do a do while loop, do while is valid. So then in here, because this customer info, so customer info, this is a one that in the structure. So let's get this one up, right? So, and also in .h file, I mentioned you need to use in this kind of format, right? And so structure now will define a new data type now. And so the new data type has a string, names, and double, right? And this is what we call a forward declaration, because what it does is I have another function that call name of the best customer, and it's a function I use, top customers, and so I declare that. The reason I do that is inside here, right? Inside the main program, right? And I start using it. I start using this best customer. You say, well, where is the best customers? Nothing here, right? And which is okay, because this is just a program where I'm not linking it. And then I use a vector, right? A vector of a customer, and customer is this, is a data type, right? So I did this customer, and then here is my customer, right? And then inside here, when you try to accessing and the variable in here, right? Then you use a dot. That's the reason I have here saying get the price, then customer dot price. Okay, so that means I want to get this value, and this is a part of this customer as well, right? And once I talk about the also class object, there's a similar kind of format. So today just give you a little, a peek how we're going to using it. So now also for data input, right? You can use the cin fail. Cin fail, what it does is, for example, this is price is double. What happens if I enter in alphabet? Well, then it will fail. It will fail, then you say, okay, I want to clear, just clear the failure flag. And ignore, that means whatever I typed in this 9, I just ignore 10,000, 1,024 characters until I see a new 9, right? So that means I just throw away everything I just typed it. Valid equal to false. I say, no, they did not give me a valid input. Now I say, please enter valid again. If it's valid, I'll get the number. I also clear everything. And then I just continue asking you to give me a valid number for the price. And after that, right, and I using less than 0 as a centennial numbers and to get out of it. And then I ask you customer info. So once I get that, right, the customer info has the price and I have the name. Then I use a vector, I push back. I push everything back into my vector, similar to the one we did, the value, right? Integer or double. It's just a data type. Now I have a data type. I push it back, right? And then I really don't need this. I don't know why I put this one there. I probably was doing something else. This one is, yeah, I don't need an I. I is redundant. Yeah. So this one just continue doing that, right? So then, here is a function, right? So in your programs, I expect you, okay, documentations for your lab 1 and all the lab in the future, right? I want you document for the main program, what is the purpose of the program? The program description. Remember in the lab submission, the first part is a program description. You can just put it here and then screenshot, I'm fine. You must give me a description of the program, right? What it does, and also a little algorithm. How do you achieve? How do you do it, right? So to tell me a little bit about this is a documentation that is required once you start working in the industry. That everything must be well documented because you're not the only one gonna read your own programs. Other people gonna read it as well, or you're gonna read it 6-7 months down the road or a year. You may not remember what you wrote. And And here, right, I also define the customer.h file, right? So that is where you always want to separate. The .h file only should contain the definition, okay, the data structure itself. It should not be part of any functions in there or C++ code. And so for that, I have this a function called top customers, right? And top customers I used inside here, right? And inside here, I use the top name of best customers and the return on index, but this is not defined here, right? And when you compile, and it has to know the name. That's the reason you do a forward declaration. So that means during compile time, you're gonna say, oh, don't worry about this particular function. Just assume I have it. So during linking time, and that's where you will try to find the function where it is at, right? That's over here, and then start using it. So again, for your function, is a similar idea. All right, you need a description, and also tell me all the parameters. In this case, add param customer info. I say, oh, what is that? Oh, contain vector of customers, and I'll return or index of vector that has top sales. Okay, right away I'll be reading it. I say, oh, I know what they mean, right? So here is the vector, right? So you can also using the constant reference parameter if you don't want to make any changes to it. And so then what this one does is I say, okay, I want to define the max because I want to see who is the max, customer info. So this is a vector function. If you look at the vector of, the function I showed you earlier on the website, right? Add means is, okay, give me the first element, here's the index, the price. So now I'm gonna say, okay, assume the first one is highest sales value, right? And then I just gonna traverse through this vector from 0 to the size of this vector, right? So here's the size, and then I say, okay, add whatever the add location, right? And if the price is greater than or equal to that, right, then I will get the max. So this you can also use instead of using add, okay? Instead of this, you can also using this as well. That also will work, okay? That will also work. You can use either one, right? And so then let me just go back. Oops. And so then it will return, right? And so then another things I said in our lab, right? You also need to always do a premise first, right? And so premise, I'll give you a little code here. So so here is a premise, right? So also I have the purpose, I have this, I have all the things. So what premise does is just print out your name, right, from here, and also course info, whatever things you want to do, and also find out the current time, right? And so now with all this, I say, okay, how do I make this a program? So this is where makefile comes in. I say best customer, right? So the main program, which depends on, this .o file. .o is an object file. And that is where when you compile a CPP file, it will turn into a .o file. So I have this this program, this program, this program, and then here is linking it, right? So I say, oh, what does the best customer .o depends on? Well, it depends on this CPP. Also depends on the customer.h. What does that mean? If any value changes here, or if the timestamp is newer than this .o, it will compile. So this is a compile. And the C flag is compile, and the -C means compile, okay? So once it's done that, and here is linking it, right? So if everything, works as it is, right? And then you can just make all, right? So as you can see, and it reproduce everything. And when I run the program, right? And so you will just say written by, that's a premise first. And then here I'll say 10, right? Not a valid number, right? And 10.3, then it's okay. And SHA, right? Then the next one is say 945 dot, and right? So now I do one more, right? So let's just say 876.24, let's just say John, and then I enter a -1 to get out of it. And now it's a best customer name is Ron. And so if you're looking at this main program here, right? And you know, that's what you did, right? You're getting all those values, right? And then this function will return whoever is highest one, and then I will just printing it, right? And so this is a quick, you know, overview of a vector, of array, and the pointers, right? And also I just give you a quick review of a Makefile. And again, in the class, I have a Zoom recording. Actually, I go into way more detail on the you know, on the Makefiles. And so then next week, right? So next week, and I'm gonna talk about you know, class object now, right? So this week, just make sure you finishing and lab 1, and then start doing lab 2 as well. And another thing is the easiest. I also require you to do this lecture summary. The easiest way of doing it, just right after class, right? Just if you're attending a live one or you're watching recording, just go finish right there, right? And I'm not gonna ask you to write many pages. So this way I know at least you got some of the things I talked about, okay? So that is today's lecture. So any questions from anybody?
I have just a question. It's not a very important one, but so like I always use like the exclamation mark and then sin to flag for like or cn to flag for like a invalid like input. Is there any advantage to using the sin.fail or using the way I've been doing it?
The one you have is fine as well. So you know, so whichever way, it's just a different way of doing it. As now you can achieve what you want, I'm fine with it. Yeah.
Okay, I just wasn't sure if one was like kind of better or worse or.
Well, the thing is, you also have to make sure if you don't use ignore, you may want to try it and give something, and then sometimes the program maybe go to infinite loop, or not infinite loop. Maybe you will, you know, getting a value from the previous input. So the way you're doing it, next time just type this. This is a test. Use a space, okay, and then see whether the program will ignore the rest of the 9 as well. So that's another key thing is you want to use ignore, otherwise it will pick up the whatever in the buffer.
No, I use ignore and then I use clear too.
Okay. Yeah, then that doesn't really matter. Yeah, it does not matter. Yeah.
Thank you, Professor.
Okay, any other questions? Okay, well, thank you very much. Just remember finishing up all the lab, and the tutors are all available this week as well, and try to utilize them and get ahead. And once we start talking about class object, by then I will already assume you already know everything we talked about it. And so just make sure everything I covered, you're comfortable with. Okay, thank you very much. Have a good week, everybody.
Thank you, Professor.
Thank you, Professor.
Thank you, Professor.